Hello everyone, welcome to my YouTube channel Chemistry Quest. This is the numerical series on solutions chapter. So in this video we will be discussing about a numerical on Van 't Hoff factor, but it is based on dissociation. Based on association, we will be dealing in the next video. It is a sample problem taken from the NCERT book. So the question is zero point 0.6 ml of acetic acid, that is CH3COOH, having density 1.06 gram per ml, is dissolved in 1 liter of water. The depression in freezing point observed for this strength of acid was 0.0205 degrees Celsius. Calculate the Van 't Hoff factor and the dissociation constant of acid. So to calculate the Van 't Hoff factor, we know the formula is observed freezing point upon calculated freezing point. So we have to go back to the problem. Number of moles of acid we have to calculate, which is equal to 0.6 ml into 1.06 gram per ml divided by 60 gram per mole, because density is given here. So we have to calculate the moles from this formula, which is equal to 0.0106 mole, which is equal to number of moles of acetic acid. Now molality is number of moles of solute upon mass of solvent in kg. So moles we have already calculated about the acetic acid, 0.0106 mole, and the mass of solvent has to be in kg, but it is dissolved in 1 liter. It has to be converted into kg, so into 1 gram per ml. So the molality is 0.0106 mole per kg. This is about the first part of the problem, but it is not yet over. So we know that delta TF, that is depression and freezing point, is equal to KF into molality. So we have calculated the molality and KF is given in the question, which is equal to 1.86 Kelvin kilogram per mole. When we multiply both these terms, we get the delta TF, that is depression and freezing point, 0.0197 Kelvin. Now, as we have been asked to calculate the Van 't Hoff factor, so Van 't Hoff factor is I, which is equal to observed freezing point upon calculated freezing point. So observed freezing point, it is given in the question is 0.0205 degree Celsius. So it is written here, and calculated freezing point, it is equal to 0.0197 Kelvin. When we divide both these freezing point, we get 1.041, that is the Van 't Hoff factor. One thing which is here important to note is the strength of the acid and the depression is given of the freezing point is given in 0.0205 degrees Celsius, but here we have taken in the Kelvin, because when we take the difference to calculate the difference in freezing point, it the unit of Kelvin or Celsius will not matter. Let's calculate the second part of the question. So we have to calculate the dissociation constant of the acid. So acetic acid is a weak electrolyte and will dissociate into two ions, acetate, this is acetate CH3CO minus, and hydrogen ions, this is H plus ion, per molecule of acetic acid. If X is the degree of dissociation, suppose X is the degree of dissociation, so N into 1 minus X moles of undissociated acetic acid, NX moles of CH3CO minus, and NX moles of H plus ions. So when the acetic acid is full, that is N moles, in the beginning of the equation, when in the start of the reaction, there will be zero moles of H plus ions and 0 moles of acetate ions. But when the reaction will proceed, suppose NX moles of H plus ions are formed and NX moles of acetate ions are formed. So the acetic acid left is N into 1 minus X. So total moles of particles, and we will calculate all these particles, N into 1 minus X plus X plus X, which is equal to N into 1 plus X. So we will calculate I is equal to number of moles of particles after association and number of moles of particle before dissociation. So this is a problem on dissociation, sorry. We have to calculate in the dissociation term. So n into 1 plus x upon n is equal to 1 plus x, which is equal to 1.041. So degree of dissociation of acetic acid, which is equal to x, which is equal to 1.041 minus 1, which is equal to 0.041. So concentration of CH3COOH is equal to n into 1 minus x. So when we will multiply 0.0106 into 1 minus 0.041, we will calculate the formula to be to the concentration of acetic acid and H plus ions, we will get Nx. So 0.0106 into 0.041. When we will put the dissociation constant is the moles of particles and concentration of particles on the right hand side, that is H plus and CH3CO minus divided by concentration of particles on the left hand side. So CH3CO minus concentration into H plus concentration divided by CH3COH concentration. So the whole thing after dividing everything will come as 1.86 into 10 raised to the power minus 5. Answer. K is the dissociation constant. It has no units. So what is the important learning in this equation is we have learned the calculation of Van't factor, but the equation which is implied is the dissociation problem. Next we will see the association problem. So if you like my video, please hit the like button, share with your friends, subscribe to my YouTube channel, and don't miss to hit the notification bell for upcoming videos. Thank you and have a good day.